So in this example now, I've kept our original circuit up here, okay, left it on channel A, and then on channel B, I've added another source signal here. This one's going to be at 60 hertz and 7 volts. I kind of want you to see the difference between, what 60 hertz and 120 hertz looks like, and a difference in amplitude between the 5 volts and the 7 volts as we go through this. All right, so nothing's happening right now because I haven't hit play, so I'm going to hit play. And once I hit play, you'll see the LEDs kind of not go in sync, right? Because we got a different hertz here, different frequency going on. All right, so I'm going to double click here on the oscilloscope and bring up the signals as they're going. Now they look like a bunch of stuff just meshed together, right? So this is where it's really good and convenient that we can sit here and toggle through the different channels as we're going through here. So when we do this, all right, we get on channel A, and I'm going to take channel A and I'm going to lower it. So make sure that you click on A, and then the Y position is down here. So I'm going to take channel A and I'm going to move channel A down. Notice that the red graph, or the original function, and how do I know which one's red and blue? Well, I've color coded them. So the signal here that's red going into channel A, that's 5 volts, 120 hertz. Okay, the signal that's blue, all right, that's going into channel B, 60 hertz, 7 volts. So we can take a look at the difference here now. All right, I can put these up side by side, but it looked kind of like a big mesh, right? But we can see the difference now, and if everything's kind of lined up, if I click over here on channel B is going to let me move this one up a little bit so we can see the two different signals and how they coincide together. So remember, the blue signal is slower. It's going at 60 hertz. The red signal is twice as fast. So notice that if I pause this here, for every time the blue signal completes one period, what happens to the red signal? It's completed 2 periods. All right, so it's going at least twice as fast, and it is, right? We got 60 hertz down here that's in blue, and we got 120 hertz here that's in red, and we can see the difference. All right, I'm going to raise, let's see, let me raise channel B up just a little bit so I'm on B. I'm going to change this so it's on the nice line there. We can take a look at the different amplitude of each signal. So the amplitude of the blue signal here, right? One box is 5 volts. That's stated right here on the scale for each one of these, all right? So each one of these boxes that's over here is 5 volts high. So if I look at the red signal goes from the bottom of one box to the other. That's the amplitude, all right? And that's 5 volts. That matches what I have over here. So see over here, I got 120 hertz, 5 volts. And then if I look, this box here is the same height, it's 5 volts high. And notice if 2 boxes would be 10 volts. So this evens out, and you're going to have to approximate a little bit. But we know one box is 5 volts. And then it's not quite half of another one. But we know, we can tell it's 7, because I told you it's 7 right here. 7 volts, 60 hertz. But you're able to approximate with each one of those. All right. We could change the X position. We could change our milliseconds per division. Still the same signal, but now we can see it maybe a little bit better. All right, so we can change the X positions as well. And once again, use your markers if you want to. So let's come down here, and these signals are pretty well lined up. So I can look at the period of, I'm going to do the blue signal first, right? So the blue signal's period, the time it takes to complete one cycle, all right, is approximately 16.78. And then we're going to do the red one. I'll just leave that blue piece here, and then we'll come over here to the red signal. All right, and look, we're on the rising edge.